Good morning students. Today we are going to deal with the concept of center of mass. First definition of center of mass. What is the center of mass? The point, center of mass is the point where the total mass of the body is supposed to be concentrated. Means at the point of center of mass, whole mass of the body concentrates. For example, consider one body. Let the mass of the body is 10 kg. Now, if this is the center of mass of this body, now at this point, what is the mass? 10 kg is the mass. Means, if the body mass is 10 kg, now at this point, the total mass of the body concentrates. Therefore, mass at the center of mass is mass at the point of center of mass is nothing but mass of the body. Means the point where the total mass of the body concentrates. If the mass of the body is 100 kg, now at the center of mass is 100 kg. If the mass of the body is 50 kg, now at the point of center of mass, the mass is 50 kg. Means the total mass of the body concentrates at one single point. That point is said to be center of mass. Now here we are going to discuss about characteristics or properties of center of mass. What are the characteristics? Characteristics of center of mass. The first point, center of mass depends upon mass of the particles and the positions of the particles. For example, consider particles. I have considered three particles. One particle mass m1, another particle mass m2, second particle mass m2, third particle mass m3. Now this is the one system. System contains three particles. Now center of mass of the system may be here. If these three particles are along the same line, m1, m2, m3, this is one system. System contains three particles. Now center of mass of this three particle system may be on the line joining the masses. Here, center of mass, the position of the center of mass depends upon the masses of the particles and also orientation of the position of the particles. The second point is, for uniform mass distribution, the center of mass is at the geometrical center of a body. For example, consider one metal rod like this. This here, the mass is distributed uniformly. This is the uniform body. For uniform body, center of mass is at the geometrical center. The geometrical center of this body is, let that is O. Now this O is also will become center of mass. For example, consider a square plate. Now this is also uniform body, mass distributed uniformly. Therefore, for uniform bodies, center of mass is nothing but a geometrical center. Now what is the geometrical center? The center of this square plate is the intersection point of the diagonals. This is the center of the geometrical center of the square plate. This geometrical center is nothing but the center of mass. Like this, so for uniform bodies, center of mass is the geometrical center. For non-uniform bodies, the center of mass is nearer to the heavier side mass. For example, see this body. This is a non-uniform body. Now, the center of mass is nearer to heavier side mass. Like this. Consider two particles of equal masses m1, m2. Are separated by distance 10 cm. The two particles are equal masses. Now center of mass of this particle is present at midpoint. This is the center of mass at equal distance from the two masses. 5 cm. This is also 5 cm. If the two bodies have equal masses, therefore center of mass is at the geometrical center. It is midpoint of the line joining the two masses. If these masses are unequal, body of mass m1, consider body of mass m1, another body of mass m2. This is the line joining the two bodies. Now here the center of mass is within the heaviest body. Here center of mass means for uniform bodies, for uniform distribution, the center of mass is the geometrical center. For a non-uniform distribution, the center of mass lies towards heavier mass. This is the second characteristic of center of mass. Next, matter may be or may not present at center of mass. For example, consider the ring of mass m kg. Now this is also uniform body. Now for uniform bodies like this, where is the center of mass? The center of mass is the geometrical center. Now what is the geometrical center? What is the center of this ring? This is the center of the circle, is nothing but center of the ring. That O is that center. Since this is a uniform body, the center of the ring is nothing but the center of mass. Here, this is the center of mass. Actually, here there is no matter. This is all empty. This is a ring. Yet this for the center of mass, at the center or at the center of mass of the ring, there is no matter. All this is the hollow part. But there is the center of mass. Means at center of mass may be present or may not be present. Or matter may be present or may not present at the center of mass. But the fourth point is, the center of mass may be inside the body or may be, the center of mass may be inside the body or outside the body, but it should be within the body. What does this mean? See here. For example, this is the ring. This is the matter. Actually, material is the ring. If we see center of mass is at the center of the ring, means the center of mass is outside the matter. Outside the matter. Not in the matter. If the center of mass present at this point, then we can say center of mass is inside the body. But here, center of mass is outside the body. But it should be, here it is within the boundary. For example, if we consider center of mass of the ring here, now I am considering center of mass of the ring is this point. Center of mass of this ring is in this point. That is wrong. Why? Here center of mass is outside the body, okay, but outside the boundary. Outside the boundary. This is the boundary of the ring. Center of mass must be within the boundary of any body. It should not be outside the boundary. Now this is wrong. For example, another example, consider two bodies, a body of mass m, a body of mass m. This is the line joining the two bodies. Now center of mass presents, maybe if the two bodies have equal masses, center of mass presents at this point. Center of mass of these two bodies present at this point. Common center of mass. Means if the common center of mass of the two bodies within the bodies, in the boundary of the bodies, in the boundary of the bodies. If we consider center of mass of these two bodies here, that is wrong. So center of mass may be inside or outside the body, but it should be within the boundary of the body. Here for the ring, center of mass is outside the material, but it is within the boundary of the ring. If you consider square plate, this is the plate. Now center of mass is inside the material, inside the square plate, and also in the boundary of this square plate. If we consider the center of mass at this point, that is wrong for the square plate. Now the conclusion of the point is, the center of mass may be inside the body or outside the body, but it must be within the boundary, For example, consider three rods arranged in the shape of in the rectangular shape. Now the common center of these three rods must be within the boundary, must be in this region, not in this region. Okay, that is point number 3. Next, The moment of masses about center of mass is 0. The next point. The moment of masses. For example, consider two bodies of masses m1, m2 separated by distance. It will be d. Now the common center of mass of these two particles. Now this is one system contains two particles. Now the common center of mass of this system of particles, that will be 0.2. Now the 0.2 is the center of common center of mass of these two particles. Let d1 is the distance of m1 from the center of mass. d2 is the distance of m2 from the center of mass. Now the moment of mass is about center of mass. Moment of mass means moment of the mass m1 about center of mass. We can write m1 d1. Moment of mass m2 about center of mass. We can write m2 d2. Mass into distance of that mass from the center of mass is called moment of masses. The moment of masses about center of mass is 0. The sum of the moment of masses about center of mass 0. So I am writing mi r is equal to 0. Sigma mi r is equal to 0. Means for here two particles are there. If there are three particles, for three particle system also we can find out the common center of mass. If the system contains four particles, for four particle system also we can locate the center of mass. Means here, if the system contains n particles, I am writing like this: m sigma mi r is equal to 0. Here I is equal to 1 t1. If system contains two particles, from this we can write m1 r1 plus m2 r2 is equal to. The system contains three particles, m3 r3 plus m1 r1 plus m2 r2 plus m3 r3 equal to 0. This is called as moment of masses. Sum of the moment of masses about center of mass is 0. Now from this point we can write m1 d1 is equal to m2 d2. Moment of mass of the first particle about center of mass. Moment of the mass of the second particle about center of mass. m1 d1 is equal to m2 d2. Next, the motion of the center of mass is purely translated motion. What is translated? See here. Consider a wheel of a cycle. No, it contains spokes. This is the center of mass of the rim of the cycle or cycle wheel. Now the cycle wheel rotates like this. Now the path of the particles on the rim are complicated. That paths are complicated. Means that the particles on the rim they rotates and moves forward. Means every particle on the rim has two types of motion: rotational motion, translational motion. Means every particle motion of every particle on the rim is a combination of translator and rotatory. Translator means straight motion. Rotatory means they are rotating like this. Here, as the rim is moving forward, the all particles are in rotatory and translator motion, but the center of mass of this rim moves in only straight line. In straight line. That's why the center of motion of the center of mass is purely translator. Center of mass of a body always moves in translator motion, means in straight line motion. The next point is the position of center of mass. Means the external forces only changes the position of the center of mass. Internal forces cannot affect the position of the center of mass. Actually, we have the first Newton's statement. Every body continues its state of rest or uniform motion unless acted by any external force. Now I am telling that is like this. The center of mass of every body, continues its state of rest or uniform motion unless acted by any external force. For example, if external force acting on the body is 0, if the center of mass is at rest, means velocity of center of mass is 0, the center of mass will always present at rest if there is no external force. Otherwise, if the center of mass moves with velocity v, for example, if it moves with velocity v, if there is no external force, the center of mass continues its motion with constant velocity. Means only external forces can affect the center of mass. Internal forces cannot affect the position of the center of mass. If there is no external force, the center of mass may continues a state of rest or continues a state of uniform motion. But internal forces cannot affect the position of the center of mass or velocity of the center of mass. What are the internal forces here? What are the internal forces? Consider two bodies of masses m1, m2 are separated by distance at a distance in free space. Now, according to Newton's universal law of gravitation, m1 attracts m2, m2 attracts m1. Now, there is a attractive force on m1 due to m2. There is a attractive force on m2 due to m1. Now, these m1, m2 are, if m1, m2 are moved towards each other under the gravitational attraction force, these are moving towards each other. Like u1 is the velocity of m1, u2 is the velocity of m2. These are moving towards each other under gravitational attraction force. Where they will meet? They will meet at the common center of mass. Why they meet at common center of mass? Here the two are moving towards each other under gravitational attraction force. Here this is our system. The system contains two particles. The two particles are attracting each other. Means m1 is applying force on m2, m2 is applying force on m1. That force we can take as internal force. The internal force cannot affect the center of mass. If the gravitational attraction force between the two bodies is internal force. If m1 is moving with velocity u1, m2 is moving with velocity u2. Now what is the velocity of center of mass? Velocity of center of mass is 0. Why? The force between the two bodies is gravitational force between the two bodies is internal force. Internal force cannot affect the position of center of mass or velocity of center of mass. That's why velocity of center of mass is here 0. Similarly, Coulomb attractive force, the force between the charges. The force between the charges is also internal force. That force is said to be Coulomb force. That Coulomb force also does not affect the position of center of mass. And explosion of bomb. Bomb explodes due to internal forces. Therefore, when the bomb explodes, the position of the center of mass does not change. Why? The explosion of bomb is due to internal forces. Okay, finally the conclusion is only external forces affect the position of the center of mass. Internal forces cannot affect. What are the internal forces? Means the gravitational force between the two bodies, the Coulomb's force between the two bodies, explosion of the bomb. In the case of explosion of the bomb, that explosion of the bomb, why the bomb explodes? Because of the internal energy, because of the internal force. In that case also, the position of the center of mass does not changes. Next, these are the characteristics of center of mass. Position of center of mass of two-particle system. In one dimension. Position of center of mass of two-particle system in one dimension. In one dimension means the particles are along x-axis and the particles are along y-axis. Or it may be not considering two particles. One is m1 and the one is m2. The distance between these two particles, let it be d. Now, let O is the common center of mass of this two particle system. Consider this is the origin. Let the m1 is at a distance x1 from the origin, m2 is at a distance x2 from the origin. The distance of center of mass from the origin let be xcm. Here x1, x2 are the distance of m1, distance of the particles m1, m2 from the origin of the coordinate system. Here the two particles are only along the x-axis. That's why this is said to be one dimension. Now from this we can write. Let distance of m1 from center of mass let be d1. Distance of m2 from the center of mass, nothing from that point to let be d2. Now already we told in the properties of the characteristics of center, in the characteristics of center of mass, one point is there. The moment of mass about center of mass is 0. Otherwise, m1 d1, moment of mass of m1 about center of mass, m1 d1, mass is distance, is equal to moment of mass of the second body. This is the moment of mass of the first body. This is the moment of mass of the second body. m1 d1 is equal to m2 d1. Now from this m1, what is d1? You see here, this is the d1. This distance is from point O to, let me consider this as O dash, consider origin as O dash. Now this distance is x center of mass. This distance is x1. This is x1. This is x center of mass. This is d1. Now from the diagram we can write it. d1 is equal to x center of mass minus x1. X center of mass minus x1 is equal to d1. Is equal to m2 into d2. This is d2. Total distance is x2. This is x2. This is x center of mass. This is d2. Now from the diagram I am writing d2 is equal to x2 minus x center of mass. Now from this m1 x center of mass minus m1 x1 is equal to m2 x2 minus m2 x center of mass. Now if you rewrite this, take this m2 x center of mass this side minus m1 x1 on that side. The equation changes like this. m1 x center of mass plus m2 x center of mass is equal to, take this m1 x1 to the right side of equal to m1 x1 plus m2 x2. Now take x center of mass common here, m1 plus m2 is equal to m1 x1 plus m2 x2. Now from this we can write x center of mass is equal to m1 x1 plus m2 x2 by m1 plus. This is the position of the center of mass from the origin of two particle system. If the two particles of masses m1 comma m2 are at distances x1 comma x2 from the origin of the coordinate system. Now the distance of the center of mass of the system of particles system. If the system contains two particles, now O is the common center of mass of these two particles. Now the distance of the center of mass of these two particle system from origin is x center of mass. Now the formula x center of mass is equal to, we can write m1 x1 plus m2 x2 by m1 plus m2. Here x1 is the distance of m1 from origin, x2 is the distance of m2 from origin. X center of mass is the distance of the center of mass from origin of the coordinate system. You have to keep that points in our mind. Now in this, if center of mass, position of center of mass from m1, x center of mass from m1 we have calculated. This is the position of center of mass from origin. Now if you want to calculate distance of center of mass from m1, so what is the distance of center of mass from m1? d1 is the distance of center of mass. If m1 is the distance d1 from center of mass. Okay. If d1 is the distance of the center of mass from m1. Now by using this also I am writing position of the center of mass from m1. X center of mass is equal to m1. Now in this case, what is x1? When this is the origin, This is the x1. But we are considering this origin at m1. Now, what is the x1 value? X1 value is 0. Why? Here x1 is the distance of m1 from origin. If origin is considered m1, now x1 value is 0. That's why it is 0 plus m2 x2. What is x2? Distance of m2 from origin. Here origin is at m1. Origin is at m1. Therefore, distance of m2 from m1 is nothing but d. Therefore, in the place of x2, I am writing d. So, it will be m1 plus m2. Now, from this we can write x center of mass is equal to m2d by d. m1 plus m. Similarly, x center of mass from m2, from a mass m2, we can write x center of mass is equal to m1d by m1 plus m. In the position of center of mass from m2, position of center of mass from m1. In what is the d? D is the distance between m1 and m2 bodies. This is the position of the center of mass of this system from origin.